If I consider this to be an example tridiagonal matrix, okay, so we can identify, as the name says, there are three diagonals. One is the main diagonal, then we have one above the main diagonal, if I choose to call this empty. Then we have one below the main diagonal. So this is where the matrix information can be found. What about all other elements? In all other positions, you will have a zero entry. Okay, so this is a tridiagonal matrix. Is this clear? So how would we, now again, if I use a normal matrix that we developed in the first class of matrix, then we would set aside 4 into 4, 16 memory locations. We would use 16 memory locations. But how much of data do we have now? We have only along the 3 diagonals. We will always have, whatever be the dimension, we will have data along the 3 diagonals only, principal diagonal, above and below, one above and one below. So we have 4 plus 3 plus 3, which is 10. Now for a dimension equal to, when the dimension is 4, we have 6 memory locations wasted. As you increase the number of dimensions, then the number of memory locations that will go a waste will be huge. Now that is why we will not use a normal matrix to store data that belongs to a tridiagonal matrix. We will develop a separate class called tridiagonal matrix, in which we will store the information. Now, to be able to save the memory locations, we should know what are the valid locations, what are the invalid locations. The invalid locations are locations where we will have a data equal to 0, which is of no interest. Okay. Now to store a tridiagonal matrix, you can store it row wise, correct? If you store it row wise, then 1, 8, 5, 2, 9, 6, 3, 10, 7, 4. This is how you would store the data. If you use row wise mapping or row major order. If you use column major order, then you would save it as 1, 5, 8, 2, 6, 9, 3, 7, 10, 4. You could save the data like that. If you store it diagonal wise, I will write the diagonal In diagonal wise again you could have variations. The way in which I've written the lower diagonal first and then this and then that. Otherwise you could choose to store this first and then go to the diagonal below above. However, there could be variations in that. Only one variation I have written here. Why is this important? Because when we want to store the data, we need a mathematical formula, isn't it? We need a mathematical formula to store the data in some particular position and also to retrieve the data given the row number and column number. So let us decide to store it diagonal wise. Then the contents of 1D array will be like this. For this, let us write the indices now, so that we will come up with a mapping function. So the indices now 5. Where is 5 found?
Second row, second column.
5 is found in 2, 1, correct? Second row, first column. Where is 6 found? 3, 2. Then 7 is 4, 3, correct? Yeah? Now, where is 1 found? First row, first column. Second row, second column. Third row, third column. Fourth row, fourth column. Where do you find 8?
1, 2.
8 is found 1, 2, 2, 3, 3, 4. Yeah? Now, 2, 1, you should use the variables 2, 1 in an equation so that you get 0. You should use 3, 2 in the same equation, which should give you 1, and so on. So like that, you have to come up with the mapping functions. You can take 10 seconds to think of what the mapping function would be, and then I will give you the mapping function and we can start writing. Two, 1 should mean 0. 3, 2 should give you 1. 1, 1 should give you 3. And imagine, the mapping function should not be just okay with n equal to 4 matrix that we've taken. It should work for any n. Do whatever, just write it down. So you have to come up with a mapping function that will map these indices values to corresponding array index value, and it should work not only for this example matrix that we've taken, it should work for any matrix, any dimension. Okay, so let's start writing the class now. I will give you the mapping function. We don't have the luxury of time to wait, discuss and write, come up with a mapping function. Though it would be interesting if we could do that. I call the class tridiagonal. So mean tridiagonal. What is the information that we need to store? Data information.
of type T.
Of type T, star, I'll call it TD. We have an array that's called TD. And what other information? N. So of type int, let's store n. Now how would you give comments? You would say this is array to store elements of the matrix, and for n to store dimension data. The comments that you write, sometimes comments are enough, sometimes trace is required. If you take the example of a linked list, now if you don't give the trace, if you don't write pictorially how a list looks like, where you are changing the pointers, it will be difficult to understand your program, your logic, okay? That is required. Comments are also required, trace is also required. Nobody needs to ask you to write it. It is common sense that you include comments and traces wherever applicable. Okay? Then we'll start writing the functions. What are the functions?
Constructor.
The first one would be the constructor. Would we require any data from the user?
Yeah. N order.
Yeah. Int sz, I make it as sz.
On default value.
Which means in this example, what would the user tell? 4. That's the dimension of the matrix. If sz is confusing dimension,
Default.
then n is equal to dimension. Before that, don't I have to verify? Yeah? What is it that we need to verify? If n less than
0 or 1.
1. If n less than 1, throw bad initializers. So copy down the dimension information in n, then set aside memory. TD is equal to new T. How much of memory location do you set aside? How much of memory location do you allocate?
N plus 2 n minus 1.
N plus 2n minus 2. That's just one equation I gave you. See, n, the principal diagonal will always have n number of elements. Then the diagonal below will always have 1 less. Yes or no?
The diagonal of all.
Plus n minus 1 plus n minus 1, correct?
3n minus 2.
So what is the total
3n minus
memory
2.
location?
3n minus 2.
3n minus 2. 3 into n minus 2. It should work for any n. That's the idea. Okay? Otherwise, we could have taken it as 10 also. But that 10 is okay only for n equal to 4. So this is it for the constructor. So tilde try d would be delete the array td, delete the array td, then store is the function. It will have a return type. To store the data, the call will come from the user. The user would want to store a data. What is the information that the user will give? Data and position. Position depicted by how many variables? 2 variables, row and column. So int I, comma, int j, comma,
T.
t ampersand x. Now constant, I am letting go of constant because you should know where to add, where not to add. You can't say in class you have not constant. Now constant, ampersand, it's all a given. You know where to use, where you should not use. So you should use your discretion. Okay? Would you use a constant here? Yes, you would. So if I leave also, you should know where to use. Done? Is there any validation?
Yeah.
Yes. If I less than 1 or I can be equal to n, right? I greater than n, or j less than 1 or j greater than n, throw out of bound function. Otherwise, we have to store the value x. Otherwise, x should be put in the array called TD. In which position? For this, you need the mapping function. Okay? So, this is not straightforward. We will do switch I minus j. Switch I minus j. Now look at I minus j. What are the conditions that you have? I minus j equal to 0 for main diagonal. I minus j equal to 1 for lower diagonal, right? Below the main diagonal. And I minus j equal to minus 1 for upper diagonal. Accordingly, we have 3 mapping functions that will work for any dimension. Okay? Switch I minus j. Case 1. Case 1 is
Lower diagonal.
lower diagonal. Those are the first elements we stored. So case 1, T of what equal to x? Any guesses? I minus j. I. T of I minus 2 is x. T of I minus 2 is x. Now, for the lower diagonal elements, since they are the ones that are going to be stored first, it's okay if your equation does not have an n. Correct? Lower diagonal elements are the first ones that we are storing. So how much ever lower diagonal you have, that much you will store. So it's okay for you not to have an n in the equation. But for the other two cases, you should have n in your mapping function. Case 0, T of n plus I minus 2 equal to x, break. And case minus 1, TD of 2 into n, TD of 2 into n plus I minus 2 equal to x, break. Okay? So n plus I minus 2. So you take this one. What is n? What is n? 4. 4 plus 2.
3, no?
N. I minus 2. I think this is straightforward. Okay? So 2 minus 2, 3 minus 2, 4 minus 2. You get 0, 1, 2. When you come here, what is n? 4. 4 plus 1. 5 minus 2 is 3. 6 3.
Correct.
6 minus 2 is 4. 7 minus 2 is 5. You take any n, it will work. Okay? So these are the three valid cases. Default is compulsory. Why? Because user could have given anything, any values of I and j.
So we validated that, right?
We validated
We
that.
validated only if
But
it's-
what if it is a valid and it does not belong to any of this? This default is validation for what if it is some number within 1 and n, but which cannot have a valid number. So in default, if x not equal to 0, if x not equal to 0, throw must be 0. Throw must be 0, exception. Let the user give any value of ij that is between 1 and 4, but it should be 0. Okay? So this is end of switch. What do we return? What do we return? What do we return?
Return star this.
Star this. Why? Because this store is a member function. We would have come to the member function through some object. So whatever we did, we would have done to the same object that brought us to the store. So we would return star this, and here we would say try d
T ampersand.
d ampersand. Then this is the end of store function. Okay. Next, retrieve function. If the user wants to get a data from the matrix, then what information will the user give? Int I, int j. Now can I put a constant? Can I put a constant now? No. Constant means I am not changing. I am giving a value for x. How will we write retrieve? Will return? Will return? Okay. If we return, what is the return type?
X. Sorry, T.
T. Return type will be T because it's the data that we are returning. Okay? Can I put an ampersand? So retrieve int I comma int j. Is there any validation? Yes, the same out of bounds. Validation you'll have to do. Correct? Yes or no? Just because I and j are between 0 and 1 and n, is it a valid location? That we'll have to see. How do we see? What will you write here? You would still do switch I minus j. Case 1, how would you write now? Case 1? Exactly, yes. Return TD of I minus 2. Case 0, return TD of n plus I minus 2.
Case 0.
Case minus 1, return TD of 2n plus I minus 2. Default return 0.
Break.
Break is required. True. Default return 0. End of the retrieve function. End of the try diagonal class.